4. All right, this you already know how to do, right? Well, at least A, B, and C, I think. Right? How do you solve an equation like A? Two equal fractions. Cross multiply. We did some of that, right? Seems like I do that in all my classes. I forget which, but I thought we'd done it in here. Yeah. So you just cross. Can I skip that one, skip that one, skip that one? How about I go to D and just do the hard one?
Yeah.
So let's just go to D. Let me rewrite this one, and we'll do that one. 2.5 is to 8 as x is to 40. So 1D, 2.5 is to 8 as x is to 40. Get that right? 2.5 is to 8 as x is to 40. Yeah. So let's just do that one. So they want me to solve for x. What should I do to do that one?
Do the 2 times 2 plus 1.
This talk, 2.5 is to 8. That means like a fraction, huh? Like that, as x is to 4. Does that make sense? That they're just giving you verbiage for a couple equal fractions, aren't they? 2.5 is to x as x. 2.5 is to 8 as x is to 40. Just means two equal fractions, a ratio. All right, and then you know how to solve that. What are you going to do with the 2.5? There's a few options. What would be the easiest thing, do you think? I'm thinking decimal. I think that would be the easiest. Just make that 2.5 into 2.5, and then just use your calculator. Just zip, and just use your calculator with the decimal, you know? So then that would be 2.5 times 40 is 8 times x. What's that? That's 100, isn't it? Because it's 2.5. 40 and 40 is 80, and half of that's 20 more. It's 100. 2.5 40s. And then last step is just divide by the 8. So that one didn't turn out too bad. Is that 12.5? 12.5. 12.5. So not too bad. Just make that a decimal. And are you okay with that language? Would you recognize that on a test or something? That's two equal fractions. 2.5 is to 8 as x is to 40. Good there. All right, I'll move on. That's what it's entitled, right? Yeah. All right, so the ratio of boys to girls in a class is 5 to 6. What is the ratio of boys to all the students in class? So let's try it. So boys, change the color here. So boys to girls is 5 to 6. So boys to girls is 5 to 6. That's a fraction, right? Boys to girls is 5 to 6. And they're asking, what is the ratio? Ratio is a fraction, right? Ratio is just a fraction, one thing over the other. That's a ratio. What is the ratio of boys to all students? That's their question. So what's the ratio of boys to all students? So boys to all students. How am I going to do that? How am I going to do all students?
You add the boys and the girls together.
That makes sense? Yeah. If there's 5 boys for every 6 girls, that doesn't mean there's exactly 5 boys in the class and exactly 6 girls. There could be in the class, for example, 10 boys and 12 girls, right? That's the same as 5 to 6. It's just doubling the top and the bottom, huh? That's the same ratio. You could reduce it. It would be back to 5, 6, right? So it doesn't mean there's necessarily exactly 5 boys or 6 girls. That means for every 5 boys, there are 6 girls. They're in that ratio. So that means for every 5 boys, there must be 5 plus 6, 11 students, huh? That's exactly right. For every 5 boys, there must be 11 students because there's 5 boys and 6 girls in every group. 5 boys for every 6 girls. Is that making sense there? Let's add them up. So they're putting the total down here, aren't they? So what's the ratio of boys to all students? The answer would be 5. It would be 5 over 11. I don't even know where to write that. There's no room. So it's 5. So the answer to that part was 5 over 11. Part B, if the ratio of boys to girls, what is the ratio? Okay, can you do the same thing? The ratio of boys to girls is m to n. What is the ratio of boys to all students? So they want you to do the same thing now with letters. The same thing we just did. Let me get you a fresh screen here. Same thing we just did now with letters. So if the ratio is m to n, that's boys, over in there, boys to girls, is m to n, then what's the ratio of boys to all going to be?
M to n plus n.
Yeah, same kind of thing. How you just put the boys over the total, right? Because all is adding them up. That makes sense. When they say all, you just add them up. And then C, if 5/11ths of the class are girls, what is the ratio of girls to boys?
5 to 6.
Yeah, you just do it backwards, huh? If 11, am I going too fast? You guys ready for another one? If down here, if they're saying 5/11ths, that's of the class are girls. 5/11ths of the class. That means 5 girls for 11 people in the class. 5/11ths of the class. Class is another way of saying total, isn't it? Class is made up in total of boys and girls. How are we doing? Is that making sense? If 5/11ths of the class are girls, that means there's 5 girls for every 11 total students in the class. Again, that doesn't mean there's exactly 11 students. There could be, like we could have 22 students, for example, right? I could have 5 girls, 6 boys, and 5 girls and 6 boys. That would be 5/11ths of the class. Of the class is girls, wouldn't it? Because 5 out of every 11 are girls. How are we doing? Is that making sense? 5 out of every 11, right? Because 5 out of this 11, 5 out of this 11 are girls. 5/11ths of the class is girls. Technically, it would be 10 girls out of what? 22 people, right? There's 11 there and 11 there. It'd technically be 10 out of 22, which reduces to be 5/11ths. See how that's true? So 5/11ths of the class is girls. So if there's 5 girls for 11 people, what is girls to boys? Yeah, 5/6. The answer that was already given is correct. There must be 5 girls for every 6 boys. Let me write that. Well, they want you to write it sideways, I guess. That's girls to boys. 5 girls to every 6 boys. All right, let me know if you want to talk more about it. I'm having trouble reading you today. You give me the poker face. Let me know if it's good or bad. Number 5, on a map, a half an inch represents 5 miles. So like a key on a map. We don't do that anymore, right? We all have it on our phone. But in the olden days, back when I was a child, there were maps. There were actual physical maps, and you unrolled them and you looked at them, and they had a key in the corner, which said a half an inch equals 5 miles. So, if there's a key on a map that says a half an inch is 5 miles, and 2 cities are 18 inches apart on the map, what is their actual distance apart? So do you realize that's a ratio again? Right, so we're saying a half an inch goes with 5 miles of actual distance. Half an inch on the map is 5 miles actual distance, and then they're saying that's equal to 18 inches on the map, x miles, and then we can solve for x. Do you see how I set that up? A half an inch for every 5 miles, so 18 inches goes with how many miles? So those are 2 equal fractions again. And you know how to solve it. What do we do? Cross multiply. Diagonal, diagonal. You can just make that, whatever. I'll just leave it a half. 5 times 18. That's a half. X equals 54. 90. Right? Is that right? Yeah. Okay, so what do we do now to solve for x? How do we get x alone there? Multiply by 2. Exactly. Cancels that out. 180. 180 what?
Miles.
Yeah, that must be how many miles 18 inches represents. Is that okay? Are you good with going from those words to those two? I know we can all solve with the two fractions. That's probably the easy part for you. Are you okay with those words leading to those two fractions? Does that all make sense? Half an inch, 5 miles, 18 inches, how many miles? Okay, let's keep going. 6 looks the same to me, I think. 33 minutes, 12 pages. Yeah, same thing. Let's go down to 7, though. 7 looks more worth our time, right? Alan, Betty, Carol invest in the corporation. Ratio 4, 5, 6 respectively. They divide the profit at 24,750 proportionally, meaning according to that, that proportion ratio thing, to their investment. How much will each receive? So give that a try. Rather than me just whip it out real quick. I forgot what number we're on. Number 5. So we looked at number 5.
7.
Oh, 7? Oh yeah, that's right. I moved on down 7. 7. So anyway, whatever the number is, and I gave you a little example of 4 is to 5, $18. And we correctly found out that this would be 8 and this would be 10. That'd be $18 in a ratio of 4 to 5. So what method then did you guys come up with? And tell me what led you to that thinking. Cammie.
My method wasn't exactly that, but...
What'd you do? What'd you analyze this and think?
Well, you just have to think of it as, they each have, pieces. So it's okay, so, this person has 4 pieces of 18, this person has 5 pieces of 18.
Yeah.
So you know that you have to, use that term. You have to use that thinking in order to find out how many.
Can I throw some? I like your pieces talk. It made me think about the fraction bar thing. Maybe that'd be easier for y'all. I don't know. So what if, because I think fraction bars are a nice way to see fractions a lot of times. What if I broke it up this way for you? And 1, 2, 3, 4, 5. So this is, 4 pieces. This is 5 pieces, okay? So anyway, so we take the whole amount, the whole $18, right? We say this whole thing is $18, and they're in a ratio 4 to 5, right? 4, 1, 2, 3, 4 here, and 1, 2, 3, 4, 5 there. Yeah, just look at that. How many boxes do I have total? 9 boxes for $18. How much is in each box?
2.
Yeah, 18 divided by 9 has got to be $2. So 2, 2, 2, 2, and 2, 2, 2, 2, 2. So how much is in this section? $8, and 5 times 2, 10. Get the idea? Good. I like what you're saying, Cam. You made me think about pieces. That's a good way to think about it. So then let's go back to the actual question, what was it? 4 to 5 to 6, 24,750. So 4 to 5 to 6, 24,750. What number is that? Number 7. Okay, so what could we do? Yeah, you don't have to draw. I mean, if you can basically picture the drawing in your head, great, or the idea of what it's doing. But yeah, it's basically 4 boxes right there, right, and then 5. 1, 2, 3, 4, 5 boxes. So 4 boxes here, 5 boxes here, and then 2, 3, 4, 5, 6 boxes right there. Yeah, and we're gonna break up $24,750 among all those boxes, huh? So what do you got to do?
Since those together are 15, you divide 24,750 by 15.
Yeah, add them up. You've got a total of 15 boxes, and all the boxes are the same. So you're dividing by 15, huh? And what did it come out be? What is that number?
1650.
1650. That means each box, right? I mean 1650. So I can't squeeze them in, but you get the idea. Each box is 1650. So then, what is this right here? 4 times 1650, whatever that is. And what is this section here? 5 times 1650. What is this here? 6 times 1650. So whatever those totals are, those are your answers. That make sense on that? And do you get a deeper way to deal with more tricky fraction questions? Going down to the concept there a little bit more. Is that good? Is that how you did it? So you just got to add them up. So I want to give you that rather than saying, okay, every time you see this problem, just add these up and then divide and then multiply. I mean, do you see the difference between learning math? I call it, I guess I'm a little cruel, but I call it monkey see, monkey do. Right? I am trying to put down that kind of thing because we don't want to do math that way. We don't want to do math by just, hey, I just imitate and like monkeys do, and they have no idea what they're doing. They just imitate, right? We're people. We think. And so instead, me just telling you divide by the total, and then, I want you to be able to see what the concept is, because they're going to push you in Math 100 to deal with concepts. Anything I can answer on that? That good? Now we're not going to get through any of the questions. So Vana scored 36 goals in her soccer kicking practice. If her success to failure rate was 9 to 8, how many times did she attempt a goal? So they're asking a little bit of a different question there. So again, I want you to think, but I don't have easy access to them. All right, so Vana scored 36 goals. Her success to failure was 9 to 8. So success. So she had 9 successes for every 8 failures. That's what that means, right? That's a physical way to see 9 to 8. 9 for every 8. So that means for every 9 times when she shot at the goal, for every 9 times she made it, 8 times she missed it. Right? We good there? 9 for 8. So, what does that mean? And then it says she scored 36 goals. She scored 36. So what does that mean? How do we get 36 scores?
Her scores or her successes?
Her scores are successes, right? So if it's 9 for 8, 9 successes for 8 failures, how can I make this into 36?
Well, you could take 9 and put it over 8 and write the ratio that way, like in fraction form.
Mm-hmm.
And then you know that if she scored 36 goals, then it would be equal to 36 over whatever she failed.
Yeah, I could do it that way. Hold on with that. How about just looking at the picture for a minute? But I'll get to that actual thing. But how about just the picture for a minute? How could I make 9 into 36? What do you got to do to 9 to make it 36?
Times 4.
Times by 4. Do you see it's just 4 of these? Right? And this is going to be maybe painful to write it all out, but I'll do it. Take the painful route. Right? So this is 9 and 9 and 9. This is 8 and 8 and 8. And then one more time. Right? Then that would be 36 successes, wouldn't it? And then, what would that be? 32? 4 times 8, 32 failures. So 36 she made, 32 she missed. And what is their question? Now, what, I don't know what their question is. What is their question? How many times did she attempt? You just add them up. 36. Now, this is probably not the way. It's not the way Cammie did it for sure. It's not the way. I know that's long. I know that's totally long. And there's a quick way, and I'm going to show Cammie's quick way, and that's great if you get that. But I want to make sure that you understand what's really happening with the pictures. That makes sense. If you have those pictures in your head, then the short ways come naturally. So then you think, oh, okay, I got it. So I'll go 9 success to every 8 failure. Okay, so this is the way. Here would be the cleanest way, like what Cammie was saying. And what do we want? Let's find out what my goal. It's like a pun, but what is my desire here? How many times did she attempt? So I really want to get attempt on somewhere in there, right? So how are we going to get attempt?
It's going to be 36 plus x.
Yeah, I'm not doing it very well. Cammie, you said you put over here. You just put over here the number that she made, right?
Yeah.
Which was 36. Yeah, that's a good way to do it. 36 success over X or whatever.
Failure.
Yeah.
And then you just know that 36 plus X is the attempts.
Right. So we could just solve there for X, right? So this is another way. Just cross multiply. So 9 times X is 8 times 36. And that's some big number. 72, 144, 288. And then divide by 9. And that's 32. And then what is that 32, though? It's X. And what is X? Failures, which we already saw the other way. So if there's 32 failures, 36 successes, how many did she attempt? Again, you add them up in the end, right?
Mr. Herring,
68.
I set mine up 9 over 36 equals 8 over x. Is there a difference in the way you set it up, or?
No, yeah, good question, good point. You can set it up that way too. Yeah, so you just did 9 over 36. You were doing success over success, huh?
Mm-hmm.
Success over success, and then that'd be failure over failure, so then you did 8 over x, huh?
Yeah.
Yep, that'll work too. Get the same answer for x in the end. Yeah, ratios can be set up any way that's consistent. So 9 over 8 is 36 over x, the same as small success over big, small failure over big. That'll work the same way. X will come out the same. And add them in the end. All right. Well, I hope that was somewhat helpful. On the so